Once again, we are welcome to this class today. We'll continue where we stop on the differential equation, elementary differential equation. So share my screen, then we zoom to that place. Can you see my screen now? Can you see my screen?
Yes, sir, we can see it, sir.
Okay. So for today, we will, like I said the other time, we will continue from where we stopped. And we pray that God will help us. Okay, let's look at this. Last time, I gave us some steps to be able to solve some problems in exact solution to be able to, and I gave an assignment. Only one person sent me the work, and others did not bother to send the work. That's good. At least when you get to exam, or you will do it. When you see when you see some question like that, you will do it in exam. But I would advise you to be always be prompt to some of those key. Okay. Let's look at this solution. Solution of this one says, now let's check our steps. What are the steps do we need to follow when it comes to this type of question? One of the steps says, we need to close this and share it. So one of the things we need to steps is, number one, for the exact solution, we first of all need to look into this and key into it. Now let's look at it. The step one says what? Check whether it's exact differential equation. How do I know? My dm dy equals to dn dx. If I can establish this, it simply means it's an exact solution, exact differential equation. Then after that, if I can also if I can also, after establishing this, if I can also try as much as possible to make it equate the x, I need to integrate them. If I can integrate this one, what do I get? So if I can integrate this, what do I have? I believe you can see the screen very well. Can we all see the screen, please?
Yes, sir.
Okay.
Yes, sir.
So if I can integrate m, the x with and add g of y, then I will have what we call, if I can do this, I'll get this. If I have this, then after the differentiation, equate my differentiation to be equals to n in order to differentiate g of y. Talking about this, I'm talking about this. Then I need to solve for g prime or h of x, either of the two. It depends on the question. It depends on what the question asks you to do. Then I need to replace them. If I replace it, what do I have? Then I need to solve it. But let's look at the assignment that I gave you. What do I need to do first thing where you have the assignment? What do we do first? The first thing we need to do is let my m equals to, what is my m? My m with the x will be 2xy squared plus 3x squared. That is my m. So, and the exact solution says, look at the formula. The formula says the m dy. So anytime I have m, is going to be with the m dy will now equals to, let's differentiate this with respect to y. What do we have? We have 4x y. Do you agree with me?
Yes.
Then our n will be 2x squared y plus 4y squared. 4y cubed, rather. 4y cubed. So, and this one will be what? The n is going to be dn dx. So, if you differentiate this with respect to n, you have 4xy. Therefore, we can say that at this point, what do we say? The solution is an exact differential equation. It's an exact differential equation. So it is easier for us to do that. So it's, since the m, the y equals to the n, the x, it is exact. Now we've established step 1 that it is exact. Then step 2 says what? We pick the f. We have the f, the y, which is the same thing as equals to our 2x squared y plus 4y cubed. Now that we have this, then we need to integrate both sides with respect to y. Integrate both sides with respect to y. Look at this. Let's go back to the step 2. Is either we pick this, remember, in step 2, which of them are we using? If you pick this one, will be with, if you pick m, it will be, we integrate this. Which, if you pick y, if you pick n, you do this. So either of the two. Now we already used m in the first phase. let's use let's use the second equation in this one and see what we have. So when you now integrate both sides. So what do we have? So we have, in this case, to be capital F x comma y equals to integral of 2x squared y plus 4y cubed dy. If you go back to the second, if you are taking, remember, we are using n. This is one we are using. So if you're using n, look at it, it's here. So you integrate the n with respect to y. If it is m, you integrate it with respect to x. Please don't forget that two things. So we move on. Now, at this point, what do we need to do? Let's integrate with respect to y and add h of x to it. So it's going to be 2x cubed, 2x squared rather, because it's with over y squared over 2 plus 4y raised to power 4 divided by 4. Everything plus h of x. You remember, when you integrate such things, you always add plus c as a constant. But in this case, we add h of x because we remember it's like a partial differential equation you are solving. Just have the mindset that, oh, I'm solving partial differential equation that have x and y, and I'm integrating, and I need to add a constant of x into it. If I'm integrating with respect to y to x now, I will add a constant of y into it. So please take note of that. So in this case now, we can have these two will go with this, 4 will go with this. So at the end of the day, we can say the f, the x will now equals to, okay, let me just write this one first. This is equals to x squared y squared plus y raised to power 4 plus h of x. Right. So now that we have this, our f of s comma y. Now the question is this. We can call this one, let's say equation 1. No, my equation 1 now that we have here, what do I need to do? I need to differentiate it with respect to x. Remember, because the constant, the one we added to here is x. If it is y, you differentiate with respect to y. So we differentiate this one with respect to x. The f, the x will now be what? 2xy squared. Now, this is y. Y will be what? 0, because it's a constant in this case. Then I cannot differentiate my variable that contains x. It will now be plus h prime of x. Plus h prime of x. Are we together? Now, what is the f? So we need to now equate it to, we'll go back to our n, which is up. Equate it to m. Let's go back to this step so that you understand what we are doing. So look at the step. We've done step 1, step 2, step 3 now. So we need to now solve for this h. Right? For us to find the h, how do we solve it? Then we need to replace them back to it. So let's go ahead. So in this case now that we have, we now equate it to the head that we have in order to get our h. So we now said that this particular equation, we now said that 2xy squared plus h prime of x equals to our m. Our m is what? 2xy squared plus 3x squared. Remember, you equate it to this m, this particular m that we have here. If it is this you did, if you use m with respect to y, you equate it to be n. Right. So that is what we will do. So, but in this case now that we have this, then let's see. We are looking for h prime. This goes with this. So our h prime of x will now equals to 3x squared. H prime of x is 3x squared. We don't need h prime because from equation 1, we only need h. How do we get h out of this? Integrate both sides. You can now integrate both sides. So when you integrate both sides, you have integral of h prime of x to be equals to integral of 3x squared dx, depending on the variable that is there, which is x. So you know differentiation, integration is anti-differentiation. So integration will cancel differentiation in the other side. So we have h of x to be equals to, let's integrate this side. We have 3x raised to power 3 over 3 plus c. So once we have this go with this, you have h of x equals to s raised to power 3 plus c. Now we know, we have it in the back of our mind that h of s is equal to this. We go back to equation 1, then substitute h of x into equation 1. Substitute h of s into equation 1. So equation 1 is there. We can substitute it there. So we will now have it, our equation 1 to be what? F of s comma y equals to s squared y squared plus y raised to power 4. Now plus s cubed. Right. Plus s cubed. Remember plus c, right? But if you take c out of it, what do we have? We have x squared, y squared, plus y raised to power 4 plus s3 equals to c. C there, you can claim that c is negative. Constant is constant. Whether it's positive or negative, is still a constant. So therefore, we have it to be, this is our final solution. Any question? How many of us got this one? You try it and you have the same thing, or you try it, you have other things, raise up your hands. Nobody. Okay, guys, I will strongly advise you to take advantage and make sure you solve them. I will also give us another one, but let's just move in fast because of our time and because remember, not only time, we have a very limited period we are using. Any questions so far? Any question? Deborah, any question? Adesoji, any question? Are you writing or you are just watching me as like, I can see some of you are lying down, you're enjoying yourself, it's good. Anyway.
You are writing, sir.
You are writing. Okay, for those that are writing, good. For those that are not writing, good. But I would advise you write. Mathematics, you can easily learn mathematics through writing. The more you write, the more you know. There's no how you can't substitute that. Or probably You have other materials you are using. I don't know. But some of you normally look for a summary. And let me quickly say this. Don't be deceived. There's nothing like summary when it comes to differential equation. If you see any summary there, you only see the example. The best thing is just to solve the problem. The more you solve it, the more you know. So let's move on. Now, we move to another topic, says method of underdetermined coefficients. Let's go up. Let me share my screen. Can you see my screen, please?
Yes, sir.
Oh, okay. Let's go. So the question, the topic says method of undermined coefficients. This method, it's a very interesting method which cut across some certain things you guys need to know. And I will also advise you to take your time and check, although the material, I don't know the kind of one you're using, you might not, but when you check your material, but you only need the basic anyway. How do we solve it? And what are the things they are saying from the materials? It will also be part of what you need to know when it comes to this undermine the method. But let's look at the general equation here. The general equation says a y prime prime plus b y prime plus c y equals to g of x. A y prime prime plus this and equals to g of x. When you look at it, what is prime prime means, please? Anybody?
Double derivative.
Is what?
Second order, sir.
First order. Or
Double.
what do you say? Double differentiation, right?
Yes.
You have to differentiate twice.
Yes.
Am I right?
Yes, sir.
So if you have to differentiate twice, how do you, this topic is under linear differential equation. So under linear differential equation, we have these topics. I can put it this way, linear differential equation. Under it, we have certain things to do. We've done the first order differential equation. We need to do linear and non-linear, non-homogeneous. Now, when you have non-homogeneous, what are the method of non-homogeneous? Let me just quickly say this. Under this, we have general solution. I'll come back to the general solution of linear non-homogeneous. Linear non-homogeneous equation. So now that you have this, Under these, that's where you now have two topics. And those two topics are key topics that you will always have in your paper. Part of it is method of undermined coefficients that I mentioned the other time. Number two says method of variation parameters. Variation of parameters. We will touch base on each of them, and you will also be glad at the end of the day that you have what it takes to pass the course. All you need is your own personal development, personal work. If you do your personal work very well, I tell you, the rest is simple. I will try as much as possible to break it down and to make it simple and more simple and more simple for us. But just promise that you will also work on yourself and you'll be able to solve this. Now, what are the things we need to know in this case? Now, the first topic, the first one that we'll be checking is this, is the method of undermined coefficients. And I gave us the general solution that says A, y prime prime plus B, y prime plus cy equals to g of x. Then our general y is equals to yc plus yp. Y particular, and we have constant, we have y particular and the rest. So now let's look at this. How do we solve this problem? But before we solve it, we need certain condition. They are there in your paper, in your material, but you might not be able to. But just pick this one. It said, anytime you have different form of g of x, remember I said it, that this is, we are talking about this g of x. What is your g of x will determine the model you are going to use for each of them. If your g of x is a constant, what do I equate the constant to? Let's look at it. If it is a form of linear polynomial, if it is quadratic polynomial, if it is cubic polynomial, if it is trigonometry, now let's look at it. Let's start from one. If it is constant, let's say number one, constant. If the form of my g of s is a constant, I will give us examples when we get there. And the form of, this is form of g of s. The other one is form of yp, y particular. A kind of y particular that we follow. Then when I have a constant, I have the y particular. Let me divide it. The y particular will be in this form, will be a. I will equate it to be a. Number two, if I have a linear polynomial, so my y particular will be ax plus b. Are you following me? Number three, if I have a quadratic, polynomial, I will have ax squared plus bx plus c. Please take note of this. Number four, if I have a cubic polynomial, I will need ax cubed plus bs squared plus cx plus e. Then if I have number 5 to be sine, let's say sine ax or cos as, what will happen? I'm going to have a cos as plus b sine as. Then if I now have a form of g of x to be exponential alpha x, I will go to have a exponential alpha x. So for us to solve this, we need a simple proof. It's very simple proof, but I want you to follow them so that you understand better. Let's look at this proof. Let's look at this. Remember, I gave us the theorem. I call it, the theorem is Cauchy. We call it Cauchy. Euler. That's the name of the two mathematicians that did this, that discovered it. Other differential equation. The two of them said, in the form of this, we have different form, but this form we are considering are ax squared y prime prime plus bs y prime plus c y equals to g of x. We call this one equation 1. Now, when we said homogeneous, homogeneous means equals to 0. Non-homogeneous means our g of x is not equals to 0. Right. So let's say homogeneous case. In homogeneous, when g of x equals to 0. Then when you have non-homogeneous, that is when g of x at this point is not equals to 0. Can you see it? Remember, I mentioned it up from here. We are to consider non-homogeneous aspects. But if we are to consider that, or if we are considering, you still start from homogeneous too. Let's start with the first one. For us to find the solution we are proving, we said find solution of the form y equals to s raised to power n. So let's our y from the equation we have equals to s raised to power m. So let's differentiate this. Y prime is equals to what? Who can tell us? Anybody? Y prime, differentiate this.
mx.
mx raised to power m minus 1.
Thank you. Then let's look at the y prime prime. It will be what? M into m minus 1. Do you agree? S raised to power m minus 2. Do we all agree?
Yes.
Hello?
Yes, sir. Yes, sir.
Okay, thank you. Now, our equation 1, don't forget we have equation 1 up. Then substitute. Just say you have to substitute this and this into your equation. When you substitute it, equation 1 becomes what? Let's look at it. Anywhere you see y prime, substitute the equation, what you have in y prime there. Right. So for equation 1 will be ax squared m into m minus 1 s into m minus 2 plus bx. Bx is y prime, right? We have mx m minus 1 plus c, which is y, s raised to power m equals to 0. We call this one equation 2. Now, we can now open the brackets. Always remember, when you are opening the brackets, remember the law that says this. There is a particular law, called law of indices, that says a raised to power m multiplied by a raised to power n is the same thing as a raised to power what? M plus n. Do you still remember? So what am I trying to tell us here is this. If you have ax raised to power 2 dot s raised to power m minus 2, what do we have? So we are going to have a x 2 Yes, who is helping us?
Plus
Plus
minus 2.
m minus 2.
m minus 2. Thank you. So you agree with me, this will give us a raised to power x, ax raised to power m. Do you agree?
Yes. Yes, sir.
That's what I did. Then the same thing applicable to where you have bx, because I will just write the solution down so that you won't say, where is he getting it? Remember that dot s raised to power m minus 1. This will be what? S raised to power 1 minus m minus 1. No, plus m minus 1. Right. So you have this one to be what? B s raised to power m. Take note of those 2 points that I raised. Now, let's move on. We can proceed from here by saying, let's open the brackets and see what we have. When you open the brackets, you have, if you just take x out, leave m inside. So we are going to have a, let me change this marker, a s raised to power m. The remaining one will be what? M into m minus 1. Do you agree? Plus b raised to power x m. And this one will be what? M in brackets. Or yes, it will be m in brackets. Let's just put it that way. And this will be what? Plus c into sm equals to 0. Now, in this case now, it's pretty simple for us to do. Something is common to the 3 variables. You discover that s raised to power m is common. Do you agree? I can factorize it out by saying s raised to power m is out, it's common. I said a m in brackets m minus 1, or let me just open this, plus bm plus c. Everything equals to 0. If you open the bracket of the first one, what do we have? We have s raised to power m, am squared minus am plus bm plus c equals to 0. The next thing we need to do is what? We need to make it in a quadratic way. So you agree with me if I put it this way, said s raised to power m in brackets, something is common here. Let me just use the square bracket here. So you see that I have am squared in bracket b minus a m plus c equals to 0. Now, based on our knowledge from quadratic equation, what do we do at this point? Who can tell us? If you are asked to solve this one, what will you do? So actually, you don't need to bother yourself. Remember this: b squared minus 4ac. When it's greater than 0, then b squared minus 4ac. When it's less than 0, and b squared minus 4ac when it's equals to 0. These three, we call it distinct real root. When we have it, we can easily solve them. Now, we are still on this homogeneous thing. I'm solving the homogeneous problem first. We know when we have a repeated root, real root, and please go and read about it. When do we have a real root and what does it mean? For these three conditions, you've done it before and you are still doing it. Now, on this case, this is where we will put the proof there. But now, if I'm now solving this problem and the question is in this form, look at this. Let's say y equals to c1 s raised to power m1 plus c2 s raised to power m2. That's the solution for this. When you solve it, that's the solution for this. Now, but that's not where we are going. But where we are going is, if I have the solution of this type, what do I call it? Now, let's look at it. In your book, they divided it into different phases. They divided it into repeated real roots, and they also divided with distinct real roots. Let's look at the distinct real roots. When you have real roots, distinct real roots, distinct real roots. So look at this example. Number 1. X squared y prime prime plus 7x y prime plus 8y equals to 0. So you don't need to pass through the let y equals to this, let this equals to this. We already solved the general form. The general form we solved is here. So what I need to do is to check the form of the question I have. I know my general solution for this equation. Let's call this one equation 2. My equation 2 is this. This is the solution for it. Now, all I need to do is, let me solve this one now. In my own case, I'll say, recall, the solution will be in this form. am squared plus b minus am plus c equals to 0. Record this one. Anytime I record this, I will be able to identify some of my parameters. Now, what represents A in this equation? Let's call this one for this question. Let's say equation star. What represents A in equation star? Based on quadratic equation. What is A? Anybody?
X squared.
No. S squared is variable.
Okay.
1, sir.
1.
1. Thank you. So what represents our B?
1.
B is equals to what? No.
7.
Is equals to
7.
7.
7.
And our C
7.
is equals to what?
8.
8. This, we just need coefficient of the equation you are given. You will substitute coefficient of equation inside that place. You will see what you will get. So we are going to have, look at it. We are going to have it this way. 1 multiplied by m squared plus, what is B? 7 minus 8, 1, m, right? Plus 8. Our C is 8. So everything equals to 0. So m squared multiplied by 1, m squared, plus 7 minus 1, 6m, plus 8 equals to 0. Are we not forming a quadratic equation?
Yes.
Now we can factorize this one. When you factorize this, what do you have? What can it give us? 8. And when you add them together, it will give you 6.
4
So
and
when you
2.
multiply, it
2
will
and
give you
4.
8. When you add it together, it will give you 6. Is what?
2, 4. 2 and 4.
4 and 2.
Plus 4. Then m plus 2 equals to 0. Equate each of them to be equals to 0. M plus 4 equals to 0. And m plus 2 equals to 0. M is equals to minus 4. M is equals to minus 2.
Well, this thing.
Right. Is what? Now, we can now go back to our general solution. Remember, general solution says y equals to C1. I have calculated my M1 and M2 now. This is my M1. This is my M2. Or you can call this one M1, either of the two, because it's still going to be the same. Let's say this is M1. Let's say this is M2. So if you have it this way, then you recall your general solution that you have from those proofs says C1 s raised to power M1 plus C2 s raised to power M2. Then we have it to be y equals to, what is C1? C1 is the constant, we don't know. S equals to, M1 will be what? Minus 2 plus C2, S equals to minus 4. That is the answer of what they asked you to do. So when you are given this type of question in exam, they said, solve the differential equation. This is the method they want you to use. Is that okay? Let's continue. Because of our time, but we still need to solve some. Now, let's look at the repeated real root. When you have a repeated real root, how do I know? He said, is homogeneous form repeated real root is y equals to C1 s raised to power m plus C2 s raised to power m ln x. Note this equation. Now, where are we getting this equation from? You remember I told you about these 3 conditions. When this condition says, maybe I should have explained this one for you guys. Something is missing and nobody is talking here. This is power. Right.
Addition sign.
Addition sign, right?
Yes.
Now, what is this? What is something I decided not to say something here. In this case, what represents, this is a quadratic equation, right? Your A in this case is equal to what? Anybody? And your B is equal to what? And your C is equal to what? Hello?
Hello, sir.
A is equals to what, please?
1.
Really? A is A. B is B minus A. And C is C. Right?
C.
Do you agree with me?
Yes, sir.
Because M is our variable that we are dealing with here. So if it's right, because it's the one that carries the square down.
Yes, sir.
That is why we deal with M. Others are parameters. That's why you see, look at this solution that I did now. You see, A is constant, a parameter value. B and A is a parameter value. C is a parameter value. That's why M still remain M. Now, if you go back to this, what this question is telling us that anytime I combine B squared minus 4AC and my answer is greater than 0, what does it mean? You have distinct real roots. When do I have repeated real roots? And when my everything equals to 0, what do I have? That is what I'm saying. So now we have repeated real roots. Now, we want to consider the case when we have repeated real roots. Now, how do we know about repeated real roots? Now, look at this question 2, says 9x squared y prime prime plus 3x y prime plus y equals to 0. What is A in this case, please?
A is 9.
A is 9, thank you. B?
3.
B is 3.
B is what?
3.
3.
Then C?
1.
Is 1.
So you don't need to pass through all those rigorous analysis since you've solved the first one. Then substitute it. When you substitute it, what do we have? Remember, you write this A squared, AM squared rather. Write it down. AM squared plus B minus AM plus C equals to 0. I know this is 9. I can say 9M squared plus 3 minus 9M plus 1 equals to 0. I have 9M squared plus minus 6, right? Minus 6M plus 1 equals to 0. So how do I add this one together? What do I need?
2 number.
Yes, you need what? What do we need?
That should be
We have
2 number.
3M.
We need not.
We need
M.
minus 3
That
minus
would
3.
be equivalent to 9 and 6.
What is this? What's the answer?
We need minus 3 plus minus 3.
Yes, yes.
Oh, okay. Will it give you 1?
Plus 2.
Okay.
We have to multiply 1 by 9.
3 plus 3.
Plus 3.
Is what?
Minus 3.
3 minus 3 minus 3.
No.
Do we have the same thing?
It's now minus 3.
Let's multiply this one. 3M multiplied by 3M,
That will be
9M squared. 3M multiplied by 1, minus 1, minus 3M, minus 1 times this,
Yes.
minus 3M, minus 1 times minus 1, positive 1. You have 9M squared minus 6M plus 1. Do you agree with me? Hello?
Yes, sir. We are good, sir.
Are we on the same page?
Yes, sir.
Yes, sir.
So this is just a digression. Let's move. Let's continue our work. Is here. So here now we have 3M minus 1 equals to 0. And 3m minus 1 equals to 0. Remember the question says, remember this one, repeated real root. It simply means at the point whereby your x or your m is equals to the same thing. Right. So it's going to be 3m equals to 1. M is equals to 1 all over 3. And if you do this one there, 3m equals to 1, m is equals to 1 all over 3. So since we have repeated real roots, it's going to be C1 xm plus C2 sm ln x. So you have it to be y equals to, what is C1? X, we know 1 all over 3 plus C2 S 1 all over 3 ln x. That's certain. So that's the answer for this. Now, we've done the two equations. When you have, don't forget, we are talking about homogeneous. This is your g of x. Let's go back to the beginning. Remember what I told you? When your g of x equals to 0, that is what we did now. But when my g of x is not equals to 0, what will happen? That is when we use this table. Master the table, please. Okay, let's continue. Let's look at this example. Now, number 3, we have y prime prime plus 3y prime plus 2y equals to 5. Remember, y particular and complement. We have y equals to y complement plus y particular. Now, we have y complement, we have y particular. How do we resolve this matter in this case? What are the things do we need to do? How do we solve this? Remember the general equation. What does this 5 represent, please? Hello? 5 is equals to what? You remember g of x. Hello?
Yes.
Yes, sir.
Please check your notes if you have one. Y is equals to what? G of x.
It's a constant, eh?
Is constant A. Thank you. That means our YP is equals to A. That's the meaning, right? Because G of S is not equals to 0. So how do we solve this one? Solution now. Let's Y prime equals to M. Let Y prime equals to M. Then I can say Y prime prime equals to M squared. I'm not differentiating. I'm just representing now. Right. So it's going to be, let's call this one equation star equation triangle. Equation triangle becomes M squared plus 3M plus 2. Remember that this is actually has nothing to do, because if my y prime equals to this, what happened to this? What Right. Now, we can now substitute this one. What do we have? Let's say equals to 0 now. Just for us to get our m. So we have this one to be what? M plus 2 and m plus 1 equals to 0. So at the end of the day, what do we have here? We are going to have m to be equals to minus 2 and m equals to minus 1. So in this case now, it is very obvious that our y complement is equal to C1 exponential x plus C2 exponential x. So which simply means that you can substitute for the y complement. We know the m now. M in terms of x is still the same, but we can substitute it now by saying our y complement will be C1 exponential of what? Minus x, which is m1, which is when m equals to 1, plus C2 exponential minus 2x. Now, the beauty of the thing is we need to also calculate what we call our G, our YP. Our YP is equals to G of X, which is the same thing as 5. And the YP is equals to A based on our table. Now, if it is equals to A, what do? We need to also differentiate it. We said YP prime. YP prime will be equals to differentiate constant. What do you have? 0. When you differentiate YP prime again, it will also give you 0. Then, if we can have 0, what happened to equation 1? Equation 1 will now becomes what? Our equation 1 will becomes what? Let's go back to equation 1. Equation triangle now in our own case. Look at equation triangle. Equation triangle becomes, because you have to substitute it back to equation triangle. So then we know is equals to 0. Substitute 0 here. Y prime. Remember equation triangle is what? Y prime. Please, can someone call it for me?
Y prime
Plus
3y
prime plus 2y
plus
equals to 5.
2y
Thank you.
equals
So
5.
now we know y prime to be 0, right? Substitute 0 plus 3 of 0, substitute it, plus 2. Remember A, you remember 2y is the same thing as A. The y there is referring to A because it's YP, right? Which is Y. Substitute A there. We now put our A here equals to 5. Then we have everything here is 0 equals to 2A equals to 5. What is A now? A is equals to what, please?
5/2.
5/2, thank you. A is equals to 5/2. So let's substitute. A is equals to 5/2. Now, where do we put this? Where are we coming from? Where are we going? It's very simple. We said y equals to yc plus yp. Then our yp, this is equals to yp. 5/2 equals to yp, right? Since yp initially is equals to a, and a is equals to 5/2, automatically is equals to yp. Then I can substitute it now. I have my yc, which is y complement. My y complement is here. Then I have my YP is also here, add them together, and that's your final solution. Y will now be, YP is what? C1 exponential minus x plus C2 exponential minus 2x plus YP, which is what? 5/2. That's what they ask you to do. Okay, let's look at this before our time is off. But before then, let me quickly solve this. Then next class will continue from there. Y prime prime plus 3y prime. I will continue to use this one because it has nothing to do with what we are doing. All is y, x. I will just change my g of x. You will see different g of x because g of x is actually the target. How do you say g of x is equal to this? How do we implement it? Now, you agree with me that my m is still the same. Excuse me. My y of c is still the same thing. Do you agree? Hello?
Yes. Hello, sir. Yes.
Because why? This particular side is for you just to find your m, your yc. It's for you to find your yc. Why this place is for you to find your yp. Just take note of that. And I know I've solved this one. I said the other time, the solution says m squared plus 3m plus 2 equals to 0. And I know my m is equals to -1 and -2, right? Are we there?
Yes, sir.
Then yc will be what? C1 exponential minus x plus C2 exponential minus 2x. Then in this case now, we have our yp to be equal to, now our g of x rather. What is our g of x is what? Yes.
4x plus
4x plus 5. That's our g of x. Now, what is equivalent? What do we call this g of x? In different type of equation we have. Let's go back to
Linear.
God bless you.
Linear
Is what? Linear
polynomial.
polynomial. You see it. If it is linear polynomial, you must know the type of equation you are given. If it is linear polynomial, what do we call linear polynomial? What is yp equivalent to it?
Ax plus b.
That's all.
Ax plus b.
So you have to use that. So the equivalent is, we now write it this way. We put it there. Yp is equals to ax plus b. This is linear. Now, we have yp equals to this. Then yp prime is what? How do we differentiate this? When you differentiate it, what do you have? Differentiate yp, what do you have?
4x.
A.
We have
No.
4.
No. This is g of x.
Okay.
Remember, you have nothing to do with this. G of x will just give you idea that
Okay.
you are to use the form of yp. Am I communicating?
Yes, sir.
From the table, the g of x is linear because of the nature of the equation we are given. Then we now get our yp from the table that says ax plus b. Then differentiate ax plus b. What do you have?
A.
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 Then when you are now differentiate yp prime prime, what do you have?
0.
0. Thank you.
0.
Then let's go and form equation. You call this one equation, let's say equation 1. Now, for that particular question, equation 1, then we can say that equation 1 becomes 0. Do you agree? Do I need to write equation 1 down? We have equation 1 to be y prime prime, which is what? When you differentiate is 0. Then
Yes.
you have y prime, 3y prime plus, what is y prime?
A.
Oh, y prime
A?
is what?
A.
A. Then plus, what is 2y?
That is 2A.
2y
2A
is
plus
equals to, you know y now. Y is what? AX plus B,
S plus B.
which is equals to 4x plus 5.
5.
Right? We are substituting it into this equation 1. Now, we can now write 3a plus 2ax plus 2b equals to 4x plus b. Now, we have to do a kind of abracadabra now. It's very simple. All you need to do is just to equate the coefficients. So, anyone that contains x will equal to the one with x. Anyone that contains constant will equal to one constant. That's how you solve this problem from here. So let's say we have 2a x, right? Plus 3a plus 2b equals to 4x plus 5. Do we agree? So this has a variable. This is a variable. This is what? A constant. So you see, this is also a variable. This is what? A constant. Now, all you need to do is, let's equate each of them together. The one with variable, we have what? 2a equals to what? Who can tell us?
4x.
No. If you want to do that, I already, when I put 2a, I assume x has cancelled. But let's write it together so that it won't confuse. 2ax equals to 4x. Do you agree now? Hello?
Yes.
sir.
So
Yes,
x
sir.
go with x.
Yes. 2 equal to 4.
So we have to say 2a equals to 4. A equals to what? 4 over 2, which is equals to 2. Do we all agree?
Yes. Yes.
Let's continue. So how do we solve the second one? We have it to be what? 3a plus 2b equals to 5. You know your a will be 3 into 2. Two a, 3a, right? You know a to be 2. Substitute it plus 2b equals to 5. So you have 6 plus 2b equals to 5.
Plus 5, yes.
So what do we do? We take 6 to the other side. We have 2b equals to 5 minus 6.
Minus 6.
2b equals to minus 1. B equals to minus 1 over 2. Any question?
No.
Now, what is our YP now? Our YP will be what? Let's go back. Remember YP from the day 1 is what? AX plus B. Do you agree?
Yes, sir.
Now, we know A, we know B. Substitute it. So you have it to be what? Our YP to be equals to 2x minus 1 over 2. Any question? Then what is YC? Our Y is Y complement plus Y particular, which is Y is equals to YC. YC is what? C1 exponential minus x plus C2 exponential minus 2x plus 2x minus 1 over 2. That is your final answer. Any question? So let me leave you with one question, and I want you to solve it. Against next class, I have another class any moment from now. But let me quickly drop that question for you. Do it now. Don't say, oh, I'll do it tomorrow. You might not even remember those steps. So y prime prime plus 3y prime, the same yp, the same yc rather, equals to 2x squared plus 4x plus 5. Now, what is the nature of this equation?
Quadratic.
Linear.
Oh, is it linear?
It's quadratic equation.
Quadratic equation because it's raised to power 2. Your g of s is quadratic. Then go to the table. What is quadratic nature of yp? Once you know it, you solve the problem. Look at it. Ax squared plus bcx plus c. You will solve it.
Plus BCX plus C.
So we can go back to this. Let me give you another one. I want to engage you so that by the time we meet next class, we have something to discuss. Don't just keep quiet. Take your time. If you don't practice, it is dangerous. Remember, you have to write the exam. And mathematics is funny. That's Roman figure 1. Roman figure 2 says y prime prime plus 3y prime plus 2y equals to cos 2x. What is the nature of this one?
Trigonometry.
You know it. I gave you. All you need to do is just to divide, substitute. On this note, guys, I will stop here. Any question? Is it interesting?
Very well interesting, sir.
Yes, sir, it's interesting.
Okay. Don't just say it's very interesting, but take your time and solve
It's
those
not though.
things. Go over it again and again. If you have any question, you can chat me up. I'm available. Right.
Thank you, sir.